Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be looking at some special factoring cases. So, this has actually been a requested one for me by my class. So, I'm going to be taking a look at this in depth. Now, to be able to look at the first case here, now the first case has to do with what we call a difference of squares. And I'm going to show you how this works, first of all, the same way we showed the other ones. So we're going to distribute first here in this special situation here. We're going to go and going to collect our Pokemon. Yes, yes, Pokemon Go examples are still live. Sorry. So this would be equal to x times x, which is x squared, x times a, which is ax, minus ax, and minus a squared. Now, when we're taking a look at this and we're looking at our like terms, we're going to notice that you have a plus ax and a minus ax. That's the same thing like saying I'm going to take away an apple from an apple. So I've got one apple and I'm taking away from it another apple. So I'd have 0 apples left. So this should leave me with x squared minus a squared. This is what we call a difference of squares. So I'm going to show you on the side here what it looks like in a number example. So for example, let's say I gave you x minus 2 and x plus 2. Well, once again, you're going to go Pokemon Go on it, catch all those Pikachus, these poor Pikachus, and you're going to end up getting x squared times, well, x times 2 is 2x, minus 2 times x is minus 2x, and minus 2 times 2 is minus 4. So when you look at this, you have two like terms right there, 2x minus 2x. That's like saying I have 2 apples, my friend has 2 apples, he takes away my 2 apples, leaving us with x squared minus 4x. And if you notice, what was my a value? My a value was 2. You'll notice our final answer should be a squared. Well, 2 squared is 4. So that lives up to it. And x squared, and that lives up to it, with a minus in the middle. So this leads us to a very special rule here, which is, can I go backwards with this? Well, yes, you can. I know I made my x squared minus 4 with x minus 2 multiplied by x plus 2. So if I were to make a rule here, I could say that if I have x squared minus a squared, the factor will always be x plus a multiplied by x minus a. So the answer will always be, you're going to have the a's, which obviously, how do I get the a? Well, that's just the square root of the a squared. And a plus and a minus. Let's do another example of this just so that we can get our hold on this. So in this other example here, we have x squared, we have 9. So when we're doing these type of questions, you're always trying to look for perfect squares. You want to say, is this one a perfect square, and is this one a perfect square? Well, x squared is definitely x multiplied by x. So it is the same thing multiplying itself. Therefore, I can say x squared is a perfect square. What about 9? Well, I know 9 is the same thing as saying 3 multiplied by 3. Once again, I'm multiplying the exact same number by itself. So once again, I can say this is also a perfect square. All right. Now, other popular examples of perfect squares would be the 4. You'd also have the 9, which we just saw right there. We'd also have 16. Why? Because 16 is made by 4 times 4. Now, this trick, this rule, only works when you're working with two perfect squares and have a minus in between them. So what you're looking out for is two perfect squares and a minus in between them. Okay, so if you see this, you know right away that I can take it and say my answer factored would be, well, the first one, which is x, because obviously the square root of x squared. You put a roof on top of its head, and suddenly the squared goes bye-bye. And then the square root of 9, well, square root of 9, well, that's the same thing as saying square root of 3 squared, which is the same thing as saying 3. Because whenever you put the roof, you get rid of the squared. So you're going to have 3 here, 3 here. And what else is the other part of my rule? Well, the other part of my rule is that you're going to have one of them with a plus, doesn't matter which one, and the other one with the minus. Now, if you doubt that this works, try distributing and check. So how can I check if I'm right? Well, just go Pokemon Go on it again and check whether it works. I'm going to use yellow here for Pikachu. Pikachu yellow here. So if I'm checking this, I'm going to get x times x, which is x squared, minus 3x, plus 3x, and minus 9. Well, I have a minus 3x and a plus 3x. They go bye-bye. So I'm left with x squared minus 9, which is exactly what I started with. So the rule works. Now we're going to take a look at the perfect square rule. Okay, so the next rule we're going to be looking at, this is another special case. It's called the perfect square rule. Now, in the perfect square rule, you have the same factor. That's the important thing. You have to have the same factor. When I say the same, I mean the exact same. So I have x plus a multiplied by x plus a, which, if you guys remember, it's the same thing like saying 3 times 3, which is 3 squared. 2 times 2, which is 2 squared. So if I say x plus a multiplied by x plus a, that is the same thing as saying x plus a squared. Okay? So, as we normally do, let's see how this works. Now, I put two special cases here. I put with a plus and I put with a minus to see whether this rule works for both. So, let's capture our Pokemon here. Who else is tired of this joke? Oh, sorry. So, x times x, x squared, plus ax plus ax plus a squared. So what am I noticing here with my like terms? Well, x squared is lonely. He comes down. I have ax, so I have an apple plus another apple, so that is 2 apples, and a squared by itself. Okay? So, what am I noticing here? Well, I'm noticing that my first term is getting squared. My second term is also getting squared. And for my middle, it happens to be the multiplication of my 2 terms and 2. Let's see whether that works here as well. So, get that Pokemon Go going. I'm going to use Pikachu Yellow there. So that's going to be x squared minus ax plus a squared. Once again, we have minus ax They are the same, so I can say minus 2ax plus a squared. So from this we can kind of make a general rule. And the general rule here would be, now let's use some a's and b's here. So let's say I have a plus b squared. This should always give us a squared plus 2ab plus b squared. So it should give us the first one squared, the second one squared as my last term, and finally it should give us this times this times 2. So let's see how this works in terms of numbers. So let's take a look at this example. I have x plus 2 times x plus 2. Well, this should be the same thing as saying x squared gotta put my picture lines there, x squared plus 2x plus 2x plus 4. So I'm going to have x squared. I got 2 apples. My friend has 2 apples. I'm going to add them together and get 4 apples. And then finally, plus 4. Now, if I use the rule says that I should have, so I'm going to use the rule here. So if I use the rule, my final answer should be this one squared, which is x squared. This multiplied by this times 2, which should be, well, x times 2 is 2x. Sorry about that in the background. See, my phone's agreeing with my answer. So x times 2 is 2x. Multiplied by 2 is, so x times 2 is 2x. Multiplied by 2 is 4x. And then finally 2 times 2 is 4. As you can see, they match, and it saves you so much time doing this on a test. So let's say I give you x plus 3 squared. Well, x plus 3 squared is the same thing as saying x plus 3 multiplied by x plus 3. Now you could do the distribution, collect your like terms, waste your time. Or you can just go, I know my answer should be x squared, this times this, well, 3 times x is 3x, 2 times 3x is 6x, and this one squared. If you do the distribution, you'll get the same thing. Now let's look at this in terms of factoring. So let's say the question now told you to factor this term. Now, as we saw in our simple trinomial factoring video, you normally would have to go find the what? You'd have to find what numbers multiply to give you 9 that also add up to give you 6. So you could go through this whole method, or now that you're looking at it, you can do one little check. So the first check would be, is my last and first term a perfect square? Well, let's see. X squared is x times x. So, yep, that's definitely true. What about my number 9? Well, my number 9 is 3 times 3. So, yep, that is definitely a perfect square as well. Your second check would then be, is my middle term 2 times a times b? Well, the first thing you would have to do here then is determine what your a and b is. So, if my x squared is a perfect square, then of course my a value would have to be the numbers that are multiplying together. So I have x times x, so my a is x. I have 3 times 3, so my b is 3. So 2ab would be 2 multiplied by x multiplied by 3, which would be 6x. So this is most definitely 2ab. So it satisfies all two of my rules and all three of my checks, which means the final answer will always be whatever my a value is. So what is my a? My a was x. Plus whatever my b is, my b was 3 squared. And of course, if you doubt this, expand it and test it for yourself. So that is the difference of squares rules and the perfect square rules. I hope you have understood this video, and please let me know if you have any other suggestions or questions for any other type of videos. Thank you.